Hello, and welcome to Artificial Reality is Our Reality, a podcast that studies and finds unique applications where modern technology mimics life, which is called biomimicry. My name is Arjun, and today we're discussing neuromorphic computing. So neuromorphic computing sounds like a big term, and it sounds like it's something that's very complicated, which I mean it is, but the general idea of how it works is pretty simple. The idea behind it is, first, I think it's best to understand how artificial intelligence works, because it's not exactly the same thing as neuromorphic computing. Artificial intelligence is basically where a system tries to carry out processes that typically requires human intelligence. Now with this, it is usually done on silicon-based architecture, like things that are typically meant for digital computing. And it works, but it really just holds back AI. It's essentially trying to carry out artificial intelligent functions on a platform that isn't designed for artificial intelligence. But that is where neuromorphic computing comes in. Neuromorphic computing is basically a architecture that consists of systems that mimic the brain's neural networks, and that those networks consist of interconnected neurons that communicate through electric impulses, which are called spikes. And basically with that, it is just emulating the neural network in our brain. Things such as neurons and synapses are all emulated in neuromorphic computing, and the advantage that this brings is that it allows for similar thinking to human processes, which, while artificial intelligence may reign superior in things such as like logical computing and storing, the thing that it holds back is that it doesn't really process information the same way as a human brain does in a parallel manner. But that is where neuromorphic computing comes in with the neural networks. It allows for information to be processed in a very parallel manner, which allows for learning and various other capabilities that artificial intelligence normally cannot carry out. So, what kind of applications does this have? Neuromorphic computing has applications in various things, such as pattern recognition, brain-machine interfaces, cognitive computing, and efficient learning algorithms. This allows it to have many applications in various industries, first off being the healthcare industry. In healthcare, neuromorphic systems facilitate the discovery of innovative brain computing interfaces and carries out things such as neuroprosthetics. Now, neuroprosthetics are exactly what they sound like. There are prosthetic limbs that are based off of neurological functions. And what this basically means is that these devices can be integrated with human physiology, which enables individuals with paralysis to control devices through their thoughts and regain mobility through advanced prosthetic limbs. And this transforms patient care and offers newfound independence and offering improved quality of life. Basically, this carries out prosthetic limbs that act similar as human, like regular limbs, like where you can bend your arm, you can bend your fingers and do things like that most prosthetics currently cannot already do, at least not reliably. But this changes that, and it basically allows you to have like a fully functional arm, whereas before, like say if you got like a prosthetic leg, it would kind of just be there, and it's kind of designed to, mimic the process of a leg, but without you completely controlling it. Another aspect that neuromorphic computing improves is entertainment. It allows individuals to discover new ways to create immersive virtual reality experiences because it can evaluate the user's interactions in real time. Neuromorphic computing chips allows these systems to dynamically adapt to provide richer and more engaging experiences in the virtual world. And basically exploiting that technology elevates the entertainment industry, offering audiences unprecedented levels of immersion and interactivity. Going back on the technical side of it, neuromorphic computing can actually improve studies on the human brain, since neuromorphic architecture are ideal for like to simulate brain functions and study neural networks and understand cognition without the use of an actual brain. And this will help bridge the gap between computational models and biological brains, allowing for more advances in particularly the healthcare industry, where they can maybe not only have prosthetic limbs, but other things that are controlled by the neuromorphic computing can also help improve the automotive industry, as it is discovered through autonomous vehicles that neuromorphic computing chips can enhance navigational skills because it is inspired by the brain's neural networks. And along with that, there is real-time decision making with these vehicles. Autonomous vehicles require like split-second decisions to navigate complex environments. And with neuromorphic chips, it allows these vehicles to keep up and not have any sort of lag or hesitations. And along with that, say like a specific example with this. Let's say you're driving in an autonomous vehicle and you're going down the road and it's pretty dark. You can't really see anything, but of course your headlights are showing, but they only show like a whatever like is in front of you. If you want to look like beside of you or behind you, let's say there's no cars, you don't really know. So you're keeping an eye out around you, trying your best, and then out of nowhere, a deer pops out from your side. With the autonomous neuromorphic computing chip running real time, it is already detecting your general environment and will see this, and due to the real time and quick speed of these neuromorphic chips, it'll be able to swerve out of the way effectively. The current companies working on neuromorphic chips are two main big ones, which is IBM and Intel. IBM's chip is called True North, which is a neuromorphic chip designed to simulate a network of 1 million neurons and 256 million synapses, which demonstrates the potential for large-scale applications with this particular chip. The Intel Loihi is more designed for applications for like real-time learning and adaptive processes, not exactly for large scale, but it's mainly for like something smaller, such as like autonomous vehicles, where it can carry out processes very quickly. So today we've covered neuromorphic computing. We've talked about the various benefits it has for the world in various industries that it can benefit, such as the healthcare industry, entertainment. It could also improve defense for companies or countries. And along with that, of course, it has many potential benefits for autonomous vehicles. As neuromorphic computing evolves and develops, it is still a pretty new technology. It will have more applications in many other industries as it is a growing market. Thank you so much for listening to this podcast.